Hi dear students. So in previous lecture we have studied guided media and unguided media. So today we are going to study the multiplexing. This is again one of the important concepts in networking, that is multiplexing. So now let us see what is meant by multiplexing. Multiplexing is the process of combining multiple signals into one signal and transmitting that signal through a common channel. So it is nothing but combining more than one signal, means multiple signals into one signal and transmitting that single signal through a common channel. That is called as multiplexing. So now let us study the definition with the help of this diagram, whatever you can see on screen. So now see here, in that diagram, this is MUX. MUX represents multiplexer. DEMUX represents demultiplexer. Clear? So here you can see, for multiplexer there are n input lines, right? That means there are n signals, n number of signals, means multiple signals. So these multiple signals, these n multiple signals, we are going to combine using the multiplexer. Clear? And then we are transmitting the combined signal as a single signal. Clear? So that single signal we are transmitting through a common channel. Clear? One link means one common channel we are using. So that single signal we transmit to a demultiplexer here. Then what is the work of demultiplexer? So that demultiplexer will receive a single signal, then it will distract, means it will divide, or it will fetch, or it will retrieve n number of signals from a single signal what it has received. Clear? So multiplexer will combine the multiple signals into single signal. Demultiplexer will remove n number of multiple signals from a single signal. Clear? So that is why it is multiplexer and demultiplexer, and that process is called as multiplexing and demultiplexing. So once again I will repeat multiplexing and demultiplexing here. So multiplexing means it is the process of combining multiple signals into a single signal and transmitting that single signal through a common channel. Clear? It is called as multiplexing. Demultiplexing means retrieving multiple signals from a single signal that has received from source or multiplexer. This process is called as demultiplexing. Clear? Understood? Okay, now what is the use of multiplexing then, or what is the advantage? So here consider one signal is there. To transmit that signal we need 100 frequency. How much frequency we need? 100 Hz. And whatever channel we are using to transmit, its capacity is 1000 Hz. How much its capacity? 1000 Hz. So if that signal 1 we transmit through the channel which is having 1000 Hz capacity, then 900 Hz remaining capacity of that channel is wasted there. Why? Because we are transmitting a signal which is of 100 Hz and channel capacity is of 1000 Hz. So remaining 900 Hz is unused, means that is wasted. So in that case what we can do is we can utilize that channel capacity for better use by transmitting more than one signal through that channel. Understood? So it will provide better use of or utilization of channel. So to do that, what we do is, whatever signals we are transmitting through that common channel, we combine them and we transmit them as a single signal. So this is nothing but multiplexing. Hope you understood why we use multiplexing in data transmission. Clear? Okay, now, so while transmitting multiple signals, we use the same channel, right? But to transmit various signals over the same channel, it is essential, means it is necessary to keep them apart. So one signal, signal 1 must be kept apart, means far away from signal 2. Like that, signal 2 must be kept, means must be transmitted apart from signal 3. Clear? Otherwise, what happens is all signals get combined and receivers may not receive correct data. Receiver may receive combined signal which doesn't mean anything for receiver. Understood? So now what we do is we keep them apart. While transmitting multiple signals, we keep them apart. So it will not interfere with each other. One signal cannot interfere with another signal. And that we can do, means we can separate such signals using a device called safeguard. So between each signal we use the safeguard there. So let us see on screen. So here what we do is, this is the, consider this is the first signal and this is the second signal. So in between each signal, while combining them, we use some safeguards here. So maybe safeguard 1, safeguard 2, safeguard 3, like that. Understood? So what these safeguards will do is, they will avoid interference of one signal with other signal. Understood? Okay, now let us move to the next concept, that is types of multiplexing. So in multiplexing there are 3 types, that are frequency division multiplexing, wavelength division multiplexing and time division multiplexing. Okay. In short, we can call them as FDM, WDM and TDM. FDM means frequency division multiplexing. What is mean by WDM then? Wavelength division multiplexing. TDM means time division multiplexing. So let us study one by one here. In today's lecture I am going to explain the first one, that is frequency division multiplexing, that is FDM. So let us see what FDM means. FDM is a frequency division multiplexing. So this is the diagram representation of process of FDM. Okay, so concentrate on diagram. Can you understand anything? Try to trace this diagram. You can easily understand what we have done here. Okay, now let us see. So here in this diagram we are using multiplexer and demultiplexer. Input lines means there are 3 inputs. Okay, so this is the channel 1's input, channel 2's input and channel 3's input. So in simple we can say signal 1, signal 2 and signal 3. So now what we are doing is, we are transmitting them through a multiplexer. So what this multiplexer will do is, it will combine the signal of all 3 channels and this is the combined signal. Okay. So first one is channel 1 signal, second one is channel 2 signal and third one is channel 3 signal. Okay. So to transmit this complete signal, we use a common channel. Okay. So now what we do is, whatever channel we are using here, it has some frequency, right? So its frequency we divide into 3 different parts. Okay. Consider frequency from 0 to 10. We provide for channel 1. 10 to 20 frequency we provide for channel 2. 20 to 30 frequency we provide for channel 3. So this is FDM. Clear? So FDM means, the name itself indicates frequency division multiplexing means In that multiplexing process, whatever communication channel bandwidth is there or complete frequency is there, that we divide into different number of or different range of frequencies. Then that frequency ranges we allot for different channels. Clear? So we consider one example here. Whatever channel we are using here, consider it is having its capacity is what? 30 Hertz. Okay. So in that 30 Hertz bandwidth, we make three parts: 0 to 10, 10 to 20, 20 to 30. 0 to 10 Hertz we allot for first channel. 10 to 20 we allot for second. 20 to 30 we allot for third. It means what? It means the channel 1 must transmit its data between the range 0 to 10. The channel 2 must transmit its data between the range 10 to 20, like that channel 3. Okay. Then demultiplexer will receive the combined signal and it will separate it and it will transmit to the respective receiver. Okay. So again I will explain FDM. So in FDM, the complete bandwidth is divided among different users as shown in this diagram. Clear? And therefore, each user gets its own bandwidth or frequency range. Its own frequency range means that is what in example I have told you, 0 to 10, 10 to 20, 20 to 30. Clear? So FDM is a transmission technique in which multiple data signals are combined for simultaneous transmission, means transmission at the same time, via a common communication channel. Clear? And FDM uses which type of signal? So FDM uses analog signal. So here in this hierarchy you can see FDM uses what? Analog signal. Clear? Okay. Next one is example for FDM. So based on example you can clearly understand what is FDM. So example is radio broadcasting, means AM and FM, amplitude magnitude and frequency magnitude. Okay. So FM, so on FM I will explain you. Consider the another diagram for FDM. So channel 1 here, just a minute. So this is the channel 1, this is the channel 2 and this is the channel 3. Okay. So all three channels are transmitting their signal at different frequency range. So channel 1 is provided with frequency range 60 to 64. Clear? Channel 2, its range is 64 to 68 and channel 3 range is 68 to 72. So after multiplexing, they are transmitted like this. Okay, concentrate on diagram. They are transmitted like this. Understood? Means what? Same communication channel is there, common channel, and among its frequency range between 60 to 72, we are providing 60 to 64 to channel 1, 64 to 68 to channel 2, 68 to 73 to channel 3. Understood? So this is how we divided frequency among different users. Understood? Okay, now come to example FM. So for FDM, the best example is FM. So you listen to FM, right? So which are the FM channels? Different FM channels you might have heard. 92.7 Big FM, right? 98.3 Radio Mirchi. Okay. So what it means by 92.7 and 98.3? Is it a channel name? Yes, it is a channel name, but it doesn't mean only the name. What it means is that particular Big FM channel range is 92.7. Clear? Its frequency range is what? 92.7. Okay. So if you want to listen to a Radio Mirchi, then what you will do? instead of searching for 92.7, you will search for frequency 98.7. When you search and when you play 98.7, you will listen Radio Mirchi, right? So what it means? At the same time, all radio channels will be broadcasting, but based on the frequency. Understood? Means what? 92.7 frequency is allotted for Big FM. 98.7 frequency is allotted for Radio Mirchi. They are broadcasting using a common channel, but their frequency is divided among various channels. Understood? So that is why for channels you can see 92.7, 98.7, 98.3. Clear? So different frequency ranges are allotted for FM. So FM is completely based on FDM, means frequency division multiplexing. Understood? So once again I will repeat the definition of FDM, that is FDM divides the bandwidth into smaller frequency ranges and transmits data simultaneously with their frequency range through a common channel. Clear? An example is FM broadcasting. So whatever FM channel uses the atmosphere to transmit its signals, that atmosphere frequency is divided into small frequencies like 92.7, 98.3, 98.7, 100.1, and such frequency ranges are allotted to different channels. All radio channels broadcasted at the same time, simultaneously. Understood? Whichever we want to listen, we will shift to that frequency range. Why to that frequency ranges? Because that is the frequency which is allotted for respective channel. Clear? So let us see one more diagram for FM. So this will represent FDM. So this will represent multiplexing processing, FDM, and demultiplexing process. Very simple here. So consider this is the channel 1, channel 2 and channel 3. User 1, user 2 and user 3. This is user 1 signal, user 2 signal, user 3 signal. So that is passed as a carrier signal here, and that is combined like this by a multiplexer. Then that moves to the demultiplexer. Okay. So here the combined signal is received at demultiplexer, and now whatever filters are there at demultiplexer, they will divide this combined signal into various signals. So filters can divide these signals separately successfully because of safeguards between each signal. Then this is the carrier of respective signal, and that is received by receiver 1, receiver 2 and receiver 3. Clear? So this is how multiplexing and demultiplexing happens in FDM. Understood? So in simple, FDM means frequency range is divided into different ranges, and each small range is allotted to various channels. It means that channel can transmit its data in that frequency range only. Understood? And then all channel ranges, all channel frequency signals are combined and transmitted as a single signal using a common channel. Hope you understood FDM. Thank you.